For the Chapter 6 review. So I'll go through these, and obviously if you have any questions beyond this, make sure you let me know. Okay, so numbers 1 and 2, we are supposed to solve these systems of equations by graphing. And I wanted to also say to make sure when you do have the option later in this assignment or on the test of what method to use, for me, if I'm going to graph, the only way I'm going to graph is if they look like numbers 1 and 2. Okay, and by what I mean by that is if you look at all of these equations here in numbers 1 and 2, all of them are in slope-intercept form, y equals mx plus b. So there's nothing I need to do. I don't need to change anything, rearrange anything, or anything like that. I can just go ahead and graph them right away. That's the only time I'm going to graph. All right, so let's get rolling here. Y equals negative 3x plus 1. So dot at positive 1 on the y-intercept. And then the slope is negative 3, so I'm going to go up 1, 2, 3, and then over to the left 1 since it's a negative slope. Or remember also I could go down 3, and then I would just have to go to the right 1. Okay, so whenever I have a negative slope, I just got to make sure I do one of each type of movement, one positive and one negative. All right, so there's my line. Let me switch colors so we can see it. Y equals x minus 7. All right, so negative 7 for the y-intercept. 1, 2, 3, 4, 5, 6. Way down here, negative 7. And remember that slope would be 1, right? 1x. And since it's positive, I'll go up 1 and then 1 to the right. And then right there, looks like they intersect each other. So I'm just going to go ahead and stop and make my line. And that point, which is at over 2, and then down 1, 2, 3, 4, down 5. Would be my answer. So remember, you can always plug those numbers into the equations. If you put 2 in for x, you better get negative 5 for an answer to check to see if you got it right, which it does. Number two, y equals negative 4x plus 3, so positive 3 for the y-intercept, negative 4 for the slope, 1, 2, 3, 4 up and 1 to the left, or 1, 2, 3, 4 down and 1 to the right. And I'm just going to do one more just to finish it off. Okay, come on, make a straight line. There we go. And again, on your paper, on your test, whenever you're doing this, try to use that straight line tool. It's going to make your life a lot easier, make your answer a lot more clear. So negative 3 here for the y-intercept. The slope is positive 2, so I'll go up 2 and 1 to the right, which lands right on that same spot, which hopefully when you're doing these, that's what happens. Hopefully you make your first line, and usually when I'm doing this, I make my first line and I make a bunch of points, because then when I make the second line, typically then it'll intersect at a point that I've already made. So that would be at the point 1, negative 1. All right, moving right along. 3 and 4, we got to solve by substitution. And then again, both of these as well. Both of these problems are set up really well for substitution. Here's what I mean by that. And this is the only time I would do substitution if one of my equations is solved for x or y and the other one is not. So for this one, I have y equals 5x plus 7, so I'm just going to go ahead and plug in 5x plus 7 for y and get rolling from there. Okay, so again, for graphing and for substitution, both. Both of those methods for me take a little bit longer to work out, so the only way I'm going to use them is if they're set up really well that way, like this. So that gives me 3x plus, and instead of plus y, it's plus 5x plus 7, and that equals negative 9, and now we just got to do our same old solving an equation. All right, so that'll give me 8x plus 7. When I combine like terms, subtract 7 from both sides, and 8x equals negative 16. Divide by 8, so x should be negative 2. All right, now all I got to do is plug in negative 2 for x into one of those two equations. I'm going to use the bottom one because that one looks like it's a little bit simpler. So I'm putting negative 2 in for x at 7. So y equals negative 10 plus 7, so y would be negative 3. So my answer would be negative 2, negative 3. And again, if I would plug that back into the top equation, negative 2 for x, negative 3 for y, that would work out. That would equal negative 9 to check my answer. All right, same thing here for number 4. You see the bottom equation again. This time it's solved for x instead of y, which is good. This is set up perfectly for substitution again. So I'm going to plug that in for x. Now this one's going to take a little bit more work because when I plug 2y plus 11 in, actually here I'll have to distribute first, which is going to add a little bit of time. And we have to make sure, like people asking questions, people's, things that I've seen, this is typically where we make mistakes. It's not the process. It's with, we miss a sign. We mess up a sign somewhere, and then that throws everything else off the rest of the problem. So really be careful and take your time, even on those parts where you feel that it's maybe easier to do, or it's things that, you've done a bunch in the past. Okay, so combined like terms, left with the two-step equation. So I got negative 16y equals negative 13 plus 77 is positive 64. Divide both sides by negative 16. And y equals negative 4. So again, go back, plug that in for y into one of my equations. Doesn't matter which one. The bottom one looked a little bit nicer to me. So x would be 3. So 3, negative 4. Okay, so again, like both of these, if you look at both of these substitution problems, finding the first variable is the part that takes the most effort and the most work, and then usually finding that second one goes a lot quicker. All right, moving right along. Now we're going to go for elimination. Now, elimination, these two are set up nice for elimination, not just because of the numbers match up or anything, but because they are all in that standard form where x and y are on the same side. Now, this one, number 5, is especially good for elimination because we have this let me get here we go, negative 2y and positive 2y. Okay, those two match up really well, so all I got to do is add these together to get those to 0. Okay, remember, that's what I think about is, how do I know whether to add or subtract? I want to get those things to 0. Negative 2y plus 2y is 0. Negative 2y minus 2y is not 0, so that's why I'm going to add. That'll give me 14x, and 34 plus negative 6 will give me 28. And here's why I like elimination. Finding my first variable was super quick, right? Unlike some of those other ones. Now, finding the second variable takes just a little more time, but really it's not too bad. I'm going to use the top equation, even though I really don't think either one of these is easier than the other. But so I'll put 2 in for x, and that gives me 18 minus 2y equals 34. Subtract 18 from both sides, and that gives me 16 divided by negative 2. Whoops, negative 2. Y equals a negative 8. So that gives me 2, negative 8. Okay, and again, if I plug in 2 and negative 8 in for x and y into that bottom equation, just to check it, that would turn out to be negative 6 when I work it out. All right, number 6. This one is not quite set up perfectly. Okay, it's set up really nicely for elimination, but these don't match up. Now, what I do see, though, is, again, I see the first thing that popped out at me was the y's, okay, in that I could multiply this by 2 to get that to equal negative 6y, and then I can add these together. So remember, we got to multiply everything by 2. So I'm going to move everything over here. So that'll give me 4x minus 6y equals negative 38. And now I can add these together again to give me 5x equals negative 10. Remember, the y's would cancel out because 6 plus negative 6 is 0. X is negative 2. I'm going to plug that into the top equation because that one looks a little bit simpler to me. So I'll add 2 to both sides to get rid of the negative 2. 6y equals 30. Whoops, divide by 6, so y would equal 5. All right, so that gives me the point negative 2, 5. All right. Now, 7a, here's a couple. Solve using any method. Number 7, this is what I'm talking about. Number 7, this is set up for substitution. These are not y equals mx plus b. X and y, none of the x's and the y's are by themselves, so that automatically makes this a good elimination problem, and that's the one that I like to use the most. Now, the bad part about this one is, these things don't match up really well. So, if I look at 8x and 6x, 8 and 6 both go into 24. Okay, so it's kind of like finding a common denominator. So I'm going to multiply this one by 3. I'm going to put it right there because it's a little bit squished. I'm going to multiply this one by 4. And that will give me 24x minus 21y equals negative 9. And then the bottom one, when I multiply that by 4, there's 24x minus 20y equals negative 4. All right, so I will subtract these because 24x minus 24x is 0. Okay, negative 21y minus negative 20y would give me negative 1y. And then negative 9 minus negative 4 would give me negative 5. Divide both sides by negative 1, and y equals positive 5. So let's use a bottom one, I guess. So 6x minus 5, and then y is 5 equals negative 1. Why did I put 2? Negative 1, there we go. So that'll give me minus 25. Add 25. And then 6x equals 24. Divide by 6, and x would equal 4. So I got 4, 5 for my answer for that one. Okay, now number 8, if I look at that one, this one, definitely not graphing, not y equals mx plus b. But this one's set up nicely for substitution because this is already the top equation is solved for x. So I'm just going to go ahead and take that and plug it in for x. All right. Not use elimination because not x and y are not on the same side. So negative 3 times y plus 2 plus 3y equals 6. Distribute. And right there, when we combine like terms, the y's drop out, don't they? So we're left with negative 6 equals 6, which no, it does not. So this one is no solution. Okay, so when it turns out to be no solution or infinitely many, it actually is a little bit nicer because there's just a little bit less work to do. Okay, all right. Next up, the dreaded word problem. So Dwight invested a total of $5,800 in 2 mutual funds. One fund earned 6% profit while the other one earned 11% profit. So the total profit was $448. Excuse me. How much was invested in each mutual fund? Okay. I know these are tricky. Okay, to write both equations. Typically, or usually, one of the equations makes a little more sense than the other. So I'll start with that one. So he invested $5,800 in 2 separate funds. This one is usually the easier equation. So we'll say X, he invested X dollars in one of them. He invested Y dollars in the other one, but together he invested $5,800 total dollars. That's usually the one that people are okay with and makes sense and get on our own. It's usually the other one. Now, the other one talks about we're going to go with the profit. 6% profit and 11% profit for a total of $448. So he made 6% profit on his, we'll say that's with the X. So I'm going to go with 0.06X plus the 11% profit would be 0.11Y, and that altogether would have to equal 448 for $448 total profit. So like the top equation, we can think of it as how much money I invested total, and then the bottom equation was how much did I make in profit? 6% from the first one, 11% from the other one, and altogether it's 448. Okay, now this one, if you think about what I just said, or if you listen to what I said on the other ones, this one looks like you might say, oh, this is set up for elimination. And it could, but the decimals really kind of throw this off for me. Okay, so what I like to do instead in this case is that type equation of x plus y equals 5,800. I can solve that for, I'm going to solve it for y, and I can do that really easily just by subtracting x. Okay, so that would give me 5,800 minus x, or negative x plus 5,800. Since I'm not graphing, it doesn't really matter. And then I can take this and I can plug it in for y with the decimals. So this one's going to be a big time calculator problem because of that. So y is 5,800 minus x. And now I'm doing the exact same thing I did on all the other ones. Distribute. I'll have to combine like terms after I figure out with my calculator what is 0.11 times 5,800. That is, I got 638 minus 0.11x equals 448. Combine my like terms. That should give me negative 0.05x plus 638 equals 448. And now we just got a 2-step equation left over, and I need to move my stuff up because I am running out of space. So subtract 638 from both sides. And that would be negative 190. Yeah, that makes sense. And finally, divide by negative 0.05. So x would equal 0.05, $3,800. Okay, so that means I'm going to put this over here, $3,800 at 6% profit is what that came from. And then to find out for the other one, all I got to do is plug this back in just like normal, and I'm going to use that top equation so I can avoid all that decimal junk. And that should give me an even $2,000 for the other one. So $2,000 at 11% profit. Okay, so, or in other words, he invested $3,800 in the first one and $2,000 in the second one. All right, mix, yeah, a little more messy when there's those decimals involved, but it's still the same type of stuff. All right, now we're to the inequality section. So we're going to graph the system of inequalities, and remember to shade each region. Reading's hard. Shade each region carefully. Okay, and that answer is where that part will intersect. So I'm going to use a lot of different colors here, and again on your iPad, you can do the same thing when you're doing this. All right, so I'll put this one in blue. Y is less than or equal to x minus 3. So just like when we graphed up above, nothing changes there. Negative 3, the slope is positive 1, so up 1 and over 1 to the right. And for inequalities, I like to put a lot of dots, as you can see. I like to put them all. Now, this one will be a solid line because the inequality is equal to. All right? And I think I have like a blue highlighter in here. Great. There we go. So now I'm going to highlight the section that would work for this. So it says y is less than. Remember, when it's in slope-intercept form, all I got to do is use that symbol. Y is less than. So that means I'm going to go below the y-intercept. Whoops. Below the y-intercept and shade that region, and then everything else that goes along with that region. I'm trying to stay in the lines like I was taught in kindergarten. Well, at least in front of that line. Everything else I don't really care about. All right, so there's the first one. Let's use this color, the red one. Y is greater than x plus 1, so positive 1 for the y-intercept. Slope again is positive 1, which I guess that's something we could have talked about at the start. The slopes are the same, which means these lines are parallel. So if this was a system of equations, this would be no solution automatically. But since it's inequalities, that's not necessarily the case. Depends on what the shading looks like. So this one says y is greater than. So that means I'm going to go above the y-intercept and shade this region, which already tells me what the answer is going to be. Because if I shade this part, and this is the only part that I can shade is above the line, there we go. And that tells me, or that you can see that there's nothing that is shaded together, right? There's no overlapping, so this still is no solution. Okay, but again, it's not because they're parallel, okay? It's because of the shading. If the inequality symbols would have been different for one of these, then we would have had something that works. We would have had an answer. Okay, so in other words, remember what this says. Remember what this means, I mean. The red highlighted part will only work for the bottom equation, or the bottom inequality, excuse me. The blue shaded part will work for the top inequality. And the part in the middle that is white, that has no shading, if I plug in numbers from there, that will work for neither of them. All right? Okay, so let's go to the next one. And let me go back to my blue. I'm going to go ahead and this one's ready to go. I know that bottom one is not, but we'll worry about that here in a minute. So y is greater than negative 2x plus 3. So there's positive 3, negative 2. I'm going to go up 2 and left 1. And then I'm going to go down 2 and to the right 1. And like I said, when I do my inequalities, I like to do all the points I can. Now, this one I got to be a little more careful with. The inequality symbol is just greater than, which means I need a dashed line. So I can't use my straight line tool, and I'll just have to do the best I can. I don't know if I can do dashed lines on here. If I can, I haven't figured it out. All right, so blue highlighter, and the symbol was greater than, which means I'm going to shade the part that's above the y-intercept, and then just make sure I shade all of the parts that are above that there too. Okay, so I just, like I said, just be careful, make sure I'm not going past that line that I made, and then after that doesn't really matter. Okay, so the other one, x minus 4y is less than or equal to 4. That one I on purpose made a little bit more difficult. So I don't like to do the x and y intercept stuff. I like to put it into slope intercept form, especially for these, because it's going to help me with my shading. Okay, so I'm going to make this and change this so that y is the only thing on this side. Okay, so the first thing I'll do is get rid of the x by subtracting it. That'll give me negative 4y is less than or equal to negative x plus 4, making sure I put the x first so it's in slope intercept form. And then I'll divide both sides by -4 to finish it off. Now, when I do that, remember, since I'm dividing an inequality, dividing both sides by negative, I have to flip the symbol. Okay, and that's like a -1/4 x. I'll divide both of these by -4. So that'll give me a positive 1/4 x minus 1. 4 divided by -4 is -1, so that's why there's a -1. -1 and -4, the two negatives would cancel each other out and make that into a positive. So I have y is greater than 1/4 x minus 1. So there's my -1. Excuse me, and then I just have to go up 1 and 1, 2, 3, 4 to the right. And next, if I try to do that again, it'll put me off the graph. So I'm going to go down 1 and 1, 2, 3, 4 to the left. And looks like that's all the further I can go there as well. So this one, and remember this one, I should have said this before I started making the line, but this one is equal to, so I'll make it a solid line like I did. And then it says y is greater than, which means I'm going to shade the region above the y-intercept, including all of this stuff over here. That's above the y-intercept as well. Okay, so when I do this, and I hope it's the same way, kind of like on your iPad, you can see how it makes that double shaded region, or the region that's been shaded twice, it makes it a little bit darker, right? Okay, so I know that this section here, right in there, that section is my answer. And the picture is my answer. I can check it and make sure. The way to do that is you pick a point. Pick any point in this region. Okay, any point. Okay, and if I was you, I'd keep it as small as possible, like this one, 2, 1. Okay, that point. If I put 2, 1 into both of these original equations, into those inequalities, 2 in for x and 1 in for y, it will work for both, or I should say it should work for both. Okay, and if you do that, you will find that it does. Okay, if you pick anything from the white region, it's not going to work for either. If you pick anything from just the red region, it'll work for the bottom one. Anything from just the blue region will work for the top one. Okay? All right, and then last, and probably the simplest problem on the whole thing I say for last is 3 -4 a solution to the system of equations? So, don't overthink it. I'm asking you, or we're asking you, is that the correct answer? Is that an answer for this? So all we got to do is plug it in and see. So I'm going to take 3 and put it in for x. I'm going to take -4 and put it in for y, and see, does that equal 22? All right, so that'll give me 6 plus 16. And this, again, I'm working it out. I would just use my calculator if I was you to make it even quicker. So it works for that one. But again, that's not the question. The question is, does it work for both? So we got to check both. So does that equal 5? So 15, or 5 times 3 is 15. 3 times -4 is -12. And here we go. 3 does not equal 5, so no, this is not a solution. Only works for one of them. All right, that is it. Like I said, if you have any questions other than this, make sure you let me know. And that's it.